Okay, in the third part, we will talk about how to apply the frobenius method. We have the problem 1. This, okay, and the condition at x equals 0, use the frobenius method to get the general solution. Okay, if you will use the frobenius method, you will check the analytics function firstly. Okay, in the equation 1, we divided by x minus, in the bracket x minus 1, we get y double plum plus, in the bracket, okay, divided by x minus 1, y plum plus 1 divided by x, in the bracket x minus 1, y equals 0. We get p of x equal this term, this, and q of x equal this. Okay, the problem at x equals 0, with substitution p0 and q0, this 0, this 0, 0, we have the number and divided by 0, and this have the number divided by 0 is infinite, or does not infinite. Okay, this make p0 and q0 is an analytics function. It make x equals 0 is singular point, and after that we check the x p of x and x square q of x. We get x p of x equal this term. They cancel x minus 1, and x square q of x equal x square minus divided by x to the x minus 1 equal x divided by x minus 1, and with substitution at x equals 0, this has the number divided by number and 0. So at x equals 0, is make p of x and x square q of x is an analytic function. It make x equals 0 is regular, singular point. Okay, after we check this is regular singular point, we can apply frobenius method. Okay, the frobenius method is substitution y equal to sum of n equals 0 to the infinity of a n x to the n plus r, and we get y plum after we differential the y, and y double plum after we do the sum. Okay, the problem is x minus 1 y double prime plus this. Okay, after we substitution, we get y double prime with differential in the second term. We get the sum of n equals 0 to the infinity of n plus r in the bracket a n x n plus r minus 2 plus this term y prime is the sum of n equals 0 to the infinity of n plus r a n x to the x plus r minus 1, and this y term. Okay, x to the n plus r equals 0. After that, we rearrangement term. We know x term the bracket this x squared minus x, and we push this term in the summation. We get the sum of n equals 0 to the infinity of n plus r in the bracket n plus r minus 1 a n x to the n plus r. Cancel the minus 2 minus x squared x. This the sum of n equals 0 to the infinity of n plus r from the same term, n plus r minus 1 a n x to the n plus r after minus 2 made it 1 is minus 1, and the second term from the last equation, the sum plus the sum of n equals 0, the 3, and n plus r a n x to the n plus r minus 1 is cancel term. Okay, and minus the sum of n equals 0 to the infinity n plus r a n x to the n plus r minus 1 from this same term, and plus y term is same term. The sum of n equals 0 to the infinity a n x to the n plus r equals 0. Okay, after that we see the variable have the two part n plus r n plus r minus 1, the exponent of x n plus r minus 1 n plus r. After that we grouping the same term. We get the sum of n equals 0 to the infinity in the bracket n plus r n plus r minus 1 from this. Okay, plus 3n plus r this. Okay, and plus 1 from this e n x to the n plus r, and the second term begin with minus n equals 0 to the infinity of in the big bracket n plus r n plus r minus 1 from this term plus n plus r from this term. Out of the bracket is a n x to the n plus r minus 1 equals 0. Okay, after that we write by substitution n equals 0 in the second term. We do the next page. After we substitution in this n equals 0, we get the three term. Okay, first term is same, the sum of n equals 0 to the infinity of n n plus r from the same term, n plus r minus 1 plus 3 in the bracket n plus r plus 1, the a and x to the n plus r. After that, substitution n equals 0. Substitution n equals 0. This term is 0, 0, 0. Okay, we get r in the bracket r minus 1 and plus r. Okay. Minus, begin with minus r in the small bracket plus r a 0 x to the r plus r minus 1. Okay. And the last term is begin the sum at n equal 1 to the infinity of this n plus r minus 1 plus n plus r a n x to the n plus r minus 1 equals 0. After that, we rearrangement the last term. Read the last term. From the exponent of x is n plus r. From the n plus r minus 1 to the n plus r rearrangement, we get the same term n equals 0 to the infinity of this n plus r. N plus r minus 1 plus t in the bracket n plus r plus 1, the same term. Okay, and this we rearrangement, we get minus r squared a 0 x to the r minus 1 r squared minus r. Okay, and the last term minus the sum of n beginning with 0 and rearrangement in this n plus r minus plus 1, because we plus 1 with substitution n plus r plus n plus r plus 1. It all of the bracket a n plus 1 x to the n plus r equals 0. With substitution n, this term with substitution n to the n plus 1, we get the exponent of n plus r minus 1 is n plus r. Okay. After that, we sum the series because the exponent of x is equal. Okay, you see it, n plus r and this n plus r. Okay, the term is same term. The right beginning x to the r minus 1 minus the sum of n equals 0 to the infinity of n plus r and n plus r plus 2 plus 1 to the a n of the bracket minus n plus r plus 1 square a n plus 1 from this term. Our bracket is x to the n plus r because the same term. Okay. After that, we get r square. Okay, minus r square equals 0. This make r square equals 0. This the initial equation. And exponent is r equal r1 and r2 equal 0. Okay, the root. After that, we have the recurrent formula is the coefficient. This term, this okay, we rewrite in the next page. Plus n r plus n plus 2 plus 1. Okay, a n minus in the bracket r plus n plus 1 all square a n plus 1 let equal 0 from the step to get the gs from the frobenius method. Okay, and we get a n plus 1 from rearrangement. The last equation is r plus n plus 2 plus 1 a n divided by r in the bracket plus n plus 1 to the 2. At r equal r1 equal 0, we get the recurrent formula is a n plus a n plus 1 equal n square plus 2n plus 1 a n plus 1 square beginning n equals 0 1 and 2 to the infinity, and a n plus 1 equal a n to the infinity. So the general solution is yx equal x to the r and r equals 0 a0 plus a0x plus a0x squared plus from the step of the frobenius in the first page to explain. Okay, and we can rearrangement in the zero term is a0 because x to the 0 is 1. It constant is only term x to the n, and a0 is 1 minus x. Okay, we choose a0 equal 1. We get y1 x equal 1 divided in the bracket. Okay, we get y1 from the step. After we get y1 from the step, you calculate y2 from this. The y2 equal y1 x integrating the factor and y1 square, because p of x is from the large page this a minus integrating p of x dx equal 3x minus 1 x in the bracket x minus 1 dx equal a minus integrating. We separate the fraction, we get, okay, minus 2 log x minus 1, and we know this logarithm term, we get minus x, and this it is exponent of the term of x minus 1. After that, we put to the below down, we get, okay, so y2 is integrating x minus 1 to the power 2 x minus 1 to the 2 dx equal, in the bracket, ln x, so we get y2. Okay, this the general solution, general term is y of x equal c1 y1x plus c2 y2x. With substitution y1 and y2 from this, we get generalization is c1 1 minus x from the y1, okay, plus c2 and the bracket log x is the general solution from frobenius. Okay, thank you for your attention.